B.2. All right. So yeah, let you see a little bit. Okay. Yeah. Then we need to move to the next topic. Okay. Yeah. All right. B.2. Second topic. Estimated cost. Total cost. What do you mean cost? Cost here, we mean the number of time units. That's the cost. We treat that because we need to pay that amount of time. So not money, but time. We know time is, precious. No. So that's the cost. Okay, yeah. All right. So let's work on the second part. We need to count the number of multiplications. We did part of it in the first half. Remember the general term, the representative, we count the number of multiplications for the general term. Yeah, that's K multiplications. But here we need to add up multiplications from all the terms. Okay, let's do the work. Yeah. All right. Yeah, because this part we already did it. All right. Yeah, we already did it. The answer is K. We did it. Okay. So then accumulate, add up all the number of multiplications, 1 plus 2 through n. You know this formula, right? Yeah. Simple formula. Okay. That's the formula. This many multiplications. To calculate this polynomial, we need this many multiplications. Okay, but we need to convert it to the number of units, time units. Then we can add the addition part, total number of units. All right, so that's calculate the total units. Addition part, 1 times n, right? Yeah, each addition corresponds to 1 unit, so 1 times n. But for the multiplication, we need to use 10. Remember our assumption 10, each multiplication equals 10 units of time, 10 times that 1/2, so you have this 5. 5n times n plus 1. Okay, so the final expression, this many units, 5n squared plus 6n, total number of time units we need to calculate this polynomial. That's the number, concrete number we can use for comparison. First part. Okay, all right. Yeah. So we know how fast or how slow this method is, but we do not have another method. We need to consider another different way to evaluate a polynomial. Then we can do comparison. So next, we need to consider a different method. Okay? Yeah. But when we consider the different method, we want to do better, right? You don't want to do worse. You want to use less time than this number here. You want to use fewer number of time units than you have here. Okay? So we need to reduce the number of units, time units. So our goal, reduce the number of time units to do the same thing. Okay? Yeah. Improvement strategy. Now we need to improvement. So what strategy should we take? Improvement strategy. Strategy, every time when we need to do something new, we may need some strategy. If it's non-trivial, if it is relatively hard. We need some strategy. Yeah, so here, the strategy, let's do observation. Now, we need to do analysis, observation for some property. All right, look at the cost ratio. Cost ratio for multiplication and addition. The numerator here, unit cost for multiplication. The subscript M means multiplication cost. Single multiplication cost, okay, over single addition cost. That's 10-to-1 ratio, okay? That number is pretty big, pretty significant, right? 10-to-1 ratio, quite significant difference, okay? All right, now, when you have certain amount of investment, suppose, because when you need to improve, you need to put your resource, right? Think about it. Put your resource, put your investment, invest your time, invest your probably your resource. Okay, yeah. When you have freedom to choose where to allocate your resource, which part you want to apply your resource on multiplication or addition? Think about this question. You have two different places to apply your precious resource. One is multiplication reduction. Another place is addition reduction. Which way you feel better? Yes, multiplication. Yeah, look at the, shares contribution in the total amount of time units. Multiplication share is this much bigger than the percentage of the addition. When you put investment on the multiplication part, you have more room to reduce the time units, right? The improvement room is bigger. And the percentage for the addition, very little. You do not have much room to do the improvement. Think about that. The room is very little. Even if you spend a lot of resource, but the rewarding is very little. Okay? But multiplication, that chunk is so big. You have much bigger room, bigger chances to reduce that big number. How about that? Think about that. So our improvement strategy, we try to reduce the number of multiplications, not additions. Additions, because that percentage is so little. Rewarding is also very little. Multiplication, the rewarding could be big. So we need to put our resource investment in the right place. It's multiplication place. Okay, so that's first consideration. Conclusion, focus more on multiplications. Okay, strategy. How do you focus on the multiplication, the strategy? Yeah, simply reduce the number of multiplication. Is there some way we can use to reduce the number of multiplications? We want to do the same thing, but with fewer number of multiplications. That's our goal. Fewer number of multiplications. Okay? Yeah. All right. Now let's do it. Implement the strategy. Here, the implementation, also very important. Although you know the strategy, you know what to do, which direction to go, but you do not have the idea how to implement your strategy. So another important part, implementation, very important. So let's look at this question. How do we implement this strategy? How do you reduce the number of multiplications? Okay. All right. Yeah. So here, the strategy. So we want to reduce this part, number of multiplications. All right. Not the first term, the second term. Okay. All right. All right, yeah, so strategy, direction to go, execution, how to get there. Yeah, now we want to, so we know the direction to go, but we do not know how to get there at this point, how to get there. So we need to explore more information. All right, yeah. How to reduce the number of multiplications? Our new question. For a new question, do we need a new strategy? Yeah. So when we have this new question, we may need a new strategy. Think about it. So we always need some strategy. Okay. Yeah. Here, for implementation, we also need a strategy. Study a simpler case. Yeah. We did that before, right? Fake coin problem, we consider simpler cases, okay? So here, for polynomial, can we study simpler polynomial first, right? Yeah. When we count the multiplications on that general term, we look at some simple cases, right? K equals 1, K equals 2, K equals 3. Then we find the answer. Here, for the polynomial, can we do the same thing here? Polynomial with 2 terms, with 3 terms, and so on. How about that? Simpler cases. Can we try to see if we can reduce the number of multiplications? Yeah. All right, let's do the work. The first case we consider n equals 2. When n equals 2, can we, so here, when n equals 2, can we reduce the number of multiplications? That's what we need to do. We need some new idea to reduce the number of multiplications. When n equals 2, we have a quadratic formula. P sub 2, quadratic formula, 3 terms. A0 plus A1x1 plus A2x2. 3 terms if, think about it. Definitely, in order to reduce the number of multiplication, we need to do computation differently, right? If you use the same computation, you get the same number of multiplication. Doesn't help. So here, we want to do different calculation. To do different calculation, here, we want to explore property. Okay? What property we can take advantage? So here, look at the last 2 terms. Can you observe some special property here? The last 2 terms. What's the property? Any special?
They share an x.
Good, share x. No, that's the property. There is a, can we call common factor? X is the common factor of those 2 terms. When there is a common factor, what manipulation you can do when you have
On the outside.
yes, factor outside, do factorization, factorize the common factor x. Okay, all right. So here, when we do that, basically we transform the problem. We change the form of the problem. For the value, we do not change, right? We change the form. The value has no change. Same value with different forms. But the result will be different. Because when you change the form, you change the structure. When you change the structure, you have different properties. Then you can take advantage of different properties to get better result. Think about that. Yeah, so this transform step is important. Okay, so let's look at how do we change the structure for new outcome. Change structure. Okay, all right. The way to change the structure, do factorization. Okay, yeah. After we factor that common factor x out, we get the right-hand side. X times the parenthesis, inside the parenthesis, x1 plus x2 times x. In this equality, the two sides have the same value, right? We do not change the value, but they have different structure. Mathematical structure are different, right? Two sides. Okay. Left-hand side, when we count the number of multiplications in the left hand, how many multiplications? If we do the calculation using the left-hand side expression. 3, 1 plus 2, 3. But answer that question again. If we count the number of multiplications using the right-hand side expression, how many do we need? 2. That's different, right? Is that number different? Can we say it's a significant reduction? Quite significant, right? 50, not 50%, 33% reduction, right? Let's say, because we use the base 3, all right? Original number is 3. Then we get 1/3 reduction. How about that? 1/3 reduction. So this direction is very promising, right? Encouraging. So we should go along this direction more. Okay? All right. So conclusion, that factorization technique can bring us this gain from 3 multiplications to 2 multiplications. Question. I'm sorry, can you repeat?
I said, as you increase the total number of terms, so say we had chosen 7 terms.
Right.
That it becomes less efficient as terms total increases. Factorization.
You say less efficient?
Yeah.
Less efficient? Yeah. All right. Yeah. That question is relatively hard to answer at this point. Because you may not push your technique far enough. The technique is factorization. How far you apply factorization technique, you may not push far enough. If we push it far enough, more efficient. So the next question is, how do we apply this effective technique, factorization technique? Next question. All right. Question. Can we generalize this idea to general M? We have to, yeah, but we need to, answer your